Hello. In this series of videos, I'll be talking about IK effects, specifically IK effects applied to arms, although the same techniques can be applied to legs as well. Some of the effects I'm going to be talking about are elbow sliding, IK stretching, non-stretchy soft IK, stretchy soft IK, and elbow pinning. So I think that's pretty much all of them. And we're not just going to be talking about them individually, we're actually going to create a control rig which has them all combined. So here's an example of one such rig. This one uses a limit controller to create the stretchy and non-stretchy soft IK, and you can see the trajectory line here. And I have a small bit of animation on this as well. And all these effects, like I was saying, are combined and work together. So we can slide the elbow, and you can see the trajectory line updating. We can turn off stretching, but still maintain the non-stretchy soft IK. And we also have elbow pinning. And elbow pinning also works with the elbow sliding. So if I move this down, then we can move this down to a position which is less than the length of the upper arm originally. So I'll just reset this. And although this is one method of creating the sort of rig that we're going to create, I'm actually not going to use the limit controller method. Instead, I'm going to use a script controller and an exponential function. The reason for that is because I just prefer the trajectory that the lower arm receives if you use an exponential function. So you can see the trajectory here is sort of like a diagonal line. It's certainly better than without soft IK on. You can see the effect there. So it is certainly worth having, but the effect of having an exponential function I just think is better. You can see the trajectory line here. It's almost like a ramp here, whereas like I was saying with the limit controller version, sort of like a diagonal line. So let's discuss the actual effects individually. So the first one is elbow sliding. And you can see how that works. And I have a more formal description of it here. So elbow sliding works by simultaneously moving the lower arm and the wrist while maintaining the overall length of the bone chain. If the lower arm is moved so that the upper arm is elongated, then the wrist must contract so the lower arm is reduced in size. So what does that mean? The stretching and squashing of these bones is happening because the child object is being translated in parent space. So this is stretching. And as we do even more, this object is stretching even more because this object is being translated. To compensate for this, the wrist has to be translated in the opposite direction. So it has to contract. So this lower arm section is getting shorter. And we can do the other direction. So now the wrist is actually getting longer, or moving in the positive x-axis of its parent, which is making the lower arm longer. And to compensate for this, the upper arm is having to be shorter, which means that the lower arm is having to move in a negative x direction in parent space to make this contract. Next is the stretchy IK. So you can see that there. So stretchy IK works by proportionately moving the lower arm and the wrist relative to the distance between an object which is positioned at or controls the upper arm and an object which moves the wrist, such as an IK goal object. Control object, I should say. So one thing I'll add to that is this effect only works when the distance between these two objects is greater than the original length of the bone chain. So everything is as expected until the length of the two objects is longer than the original bone chain, in which case the lower arm and the wrist proportionately translate along the x-axis, and that's how you get the stretching effect. Next we have the non-stretchy soft IK, and you can see what's happening there. So soft IK can be non-stretchy or stretchy. The non-stretchy soft IK works by offsetting the IK goal from the control object so that as the distance between the upper arm and the control object approaches the length of the bone chain, the IK goal will begin to lag. Okay, let's see that then. So even before the distance between these two objects is the length of the bone chain, what's going to happen is this object here, which is the parent of the IK goal, will start to lag behind. So we can increase this value to make it a bit more obvious. So you can see it beginning to lag behind. So as it happens, it's lagging behind, and then it stops at the length of the bone chain because it's non-stretchy soft IK. Next we have stretchy soft IK, and I'll just put this up to a value of say 2. So I have a bit of animation on this as well, so you can see how that works. So instead of making the IK goal lag, stretchy soft IK controls the lengths of the bones by using an exponential function to stretch the bones before the IK control object moves further away than the length of the chain. So I've set this bone chain up deliberately so that the initial position in parent space of this bone is 30, which means the length of the upper arm is 30 units. And the position of the wrist is 40, so that the position of the lower arm, sorry, the length of the lower arm is 40. Okay, and you can see if I just dial this down to 0, for example, so it's around say frame 7, if we increase this, begin to increase it, so you'll notice that the length of the chain is 70 and the current x position of the control object is 68.324, and now you can see this object here is no longer 30 units, it's actually 30.713, and this one is 40.951. So this stretching is what gives us the soft IK, and you can see the trajectory line there. And after a certain distance, what happens is the stretchy soft IK reduces to just stretchy IK. So around frame 14, we're getting the same result now as just stretchy IK. You only really want soft stretchy IK just for this section here, where the control objects are at around about the same distance as the overall bone chain. Okay, and then the last one is elbow pinning. So elbow pinning is similar to stretchy IK, but it works on a per bone basis rather than on the entire chain. This process requires the creation of another object for distance calculations. If this newly created object is used as the IK's swivel angle target, then the lower arm will appear to follow its world space position. So let's just move this out of the way. Again, I'll say that this effect only works if the distance between the newly created object, which is the elbow target, and this object is greater than the position of the lower arm. If it's not, then we just get ordinary IK, and then as soon as it's greater, we get the pinning effect. And this can happen at any sorry, we can reposition any of these helpers and get the pinning. And also, like I said, the object has been loaded in as the swivel angle target for the IK. So as we move this up, you can see it looks as though this helper is controlling the world space position of this bone here. So I'll just pop that down to 0. Okay, that's the end of the first video. Now we've gone over all the introductions. In the second video we'll actually start to create our control rig.